By the end of this video, you'll be able to backtest the strategy of buying and holding ES contracts with the risk scaling. Along the way, you'll learn the following. Market hours for ES, the self-portfolio property, the self-liquidate method. This is strategy 2 of Carver's advanced futures trading strategies. In this strategy, our goal is to buy and hold a specific number of ES contracts to achieve an annual portfolio volatility of 20%, denoted as tau. Given that the annual volatility of ES is around 16%, denoted as sigma percent, we use this formula to calculate the number of contracts to hold. Here, the multiplier for ES is 50, and we rebalance the portfolio daily. One side note, even though ES trades almost 24 hours a day, the regular trading hours for ES is from 9:30 a.m. to 5 p.m., Monday to Friday. By default, our security subscriptions only cover regular trading hours. With that out of the way, let's dive into the coding process. As usual, we start with this basic setting. Based on Carver's recommendation of starting with enough capital to trade at least 4 contracts, and considering that ES was valued around 1,000 in 2009, we will set our initial cash at $160,000. Next, we subscribe to the ES data and save the returned future object for future use. To calculate the required number of contracts, we must consider the components of the formula: the risk target tau, the annual volatility of ES, and the contract multiplier. As you see, to avoid hard coding of 50 for the multiplier, we're using the future object symbol properties contract multiplier for this. With the preparation done, we define a function that does the calculation. Here are a few key points to note. Self.portfolio.total portfolio value represents the capital in Carver's formula. Self.portfolio ES.price represents the current price of ES. Then we compare the target holding with the actual quantity held using this line. If the difference is negative, it triggers market sell order instead of a buy order. Now that we've covered these preparations, let's proceed with implementing the strategy. Each day, if it's a rolling day, we apply a similar logic as the previous video with a few adjustments. To prevent unnecessary portfolio rebalancing on such days, we utilize an instance variable self.symbol_changed_day for tracking. This ensures that rebalancing is skipped on a subsequent occurrence of the same day. Additionally, we refine the roll function. Instead of a market order to sell the expiring contracts, we employ self.liquidate, which sells all the current holdings. Subsequently, we calculate the target quantity for the new contract and execute a market order to purchase them. On days that aren't rolling days, our focus shifts to rebalancing the portfolio promptly at 10 a.m. Note how we carefully track and update the value of self.symbol_changed_day. Okay, so now we are ready for the backtesting. Alright, that's it for this video. If you have any questions or comments, feel free to leave them below. Thank you for watching and happy coding!